Okay, so we determined the time that the car and the truck will meet mathematically. There's also a way to determine this time or the meeting point graphically. So if you look at these equations, hopefully you'll recognize they look kind of like a linear equation, y equals mx plus b. And that's exactly what they are. So let's do this, for the truck, or for the car, excuse me, for the car, we have y, which in this case is our position. So if you think about a position versus time graph, remember the position is on the y-axis and the time is on the x-axis. Y equals m, which we know for a position versus time graph, the slope represents the speed or velocity, times x, which we know that time is on the x-axis. Now, plus b, but remember our y-intercept is equal to our initial position, and for the car, the initial position is just 0. Now, for the truck, we have y equals 66 kilometers per hour times t, plus, in this case, the initial position, or the y-intercept, is 0.780 kilometers. So we have these linear equations. So this is how I do this. I go to my app Desmos. You can do this on the graphing calculator as well. You can do it by hand as well, but this is easy. Now I'm going to write in my function. So we have y equals 70, so that's 76, and then x. Okay, I'm just going to make sure that's right. So y equals 76, x, perfect. That's for the car. And then for the truck, we have y equals 66x plus b 0.780. And you can see it's made these graphs. Okay, so now we kind of have to zoom in. Let's see. I like I can zoom in there a little better. Okay, so you can see for the car, which is in red, its initial position is 0. The truck's initial position is 0.780. You can see that the red slope is steeper because the car is moving faster. But you can see this point right there where the two intersect. So if you click that point, the 0.078 represents the x value, which in this case is time in hours, and then the 5.928 represents the meeting place, the x final position, and there we go. Pretty easy.